Hey 7th grade, it's Miss Hash. I'm making you this video of notes on Wednesday, our second snow day this week. My dog Lily is not so happy that I'm doing work instead of playing with her. So let's get these notes over with. Okay, so on Tuesday, you guys came into class and you solved your second packet page, right? Second packet page. And we trimmed your packet pages and we glued them into your notebook. So really quickly here, let's just review what your notebook should look like right now. So I can see here's my tab page for moving straight ahead. Flip. We should have 1.2 walking rates across from 1.1 walking rates. And then if we flip one more time, this page will be blank in your notebook, but we're going to fill it with notes today. So if your notebook is not out, it needs to be out in front of you. Have a pen or a pencil ready, and we're going to take notes. Okay, so this is 1.2 linear graphs, and then in parentheses, tables and equations. I put that part of the title in parentheses because it's not the main part of this lesson. Graphs are the main part of the lesson. So the first thing we need to do is write down a definition for a linear relationship. We've done a lot of talking about this in class, but we haven't actually written anything down. So that's the first thing I'm going to write down. Linear, or think linear, relationship. And I'm going to underline it so it stands out and I know it's important. So a linear relationship is a relationship that has a constant rate of change. Oh, and that's actually a constant rate of change between two variables. I got a little bit ahead of myself there. A relationship that has a constant rate of change between two variables. Oftentimes we use X and Y. Lately with our walkathon examples, we've been using M for money and D for distance, or we've been using T for time. So lots of different variables that we could use. We're going to do 3 examples. 2 of them are going to be linear. 1 of them is going to be nonlinear. So I'm just drawing the first quadrant of a graph using a different color. We're going to do a nice straight line. It's a line, so it's linear or linear. And in this example, our line is pointing upwards, so it is increasing. My second example is also linear or linear because it makes a straight line. So I'm going to label it. And because this one is pointing down as we read it from left to right, this is an example of decreasing. It's kind of hard to fit in there, but I made it work. This third example is going to be an example of a line that is not linear. So I'm just going to make it look really obvious that it's not straight. Just a giant squiggle. it is not linear because it's not a straight line. There are all kinds of squiggles that we could have drawn on the graph that would be not linear, but the main idea here is just recognizing that if it's not a straight line, it's not a linear graph. Let's set up an example to go with each of these graphs. We don't really need any data points, but we could just think of a general example that would fit the sketch or fit the model. So in this first one, the increasing linear, an example of this might be running 1 mile every 8 minutes. Now that's a pretty fast mile, in my opinion. And if we think about it as time is increasing, let's pretend that time is down here on the x-axis, we can see that our distance would be increasing. So every 8 minutes that goes by, we've run another mile. That's an increasing linear example. A decreasing linear example, we're going to write it right under here under this graph, would be something like taking money out of a savings account. So let's say that you've got some money in the bank, you've been collecting some money that your grandma has been giving you every year, and then you finally find something in a store you want to spend that money on. That would be a decreasing pattern because you're taking that money out. Let me make some room here. Okay. We've got one more big graph to cover, and then we will wrap up and move on to the next page. So let's go ahead and set up one more graph. This time it's going to be bigger than our first two examples. Let's see, 1, 2, 3, 4, 5, 6, 7 lines tall. And it doesn't have to be 7 lines tall. We're going to use this graph as an example. So let's set up the example over here, and then we'll draw some lines. So something that we talked about on Tuesday, as you guys did your 1.2 packet page, was the idea of steepness. Steepness is a way for us to describe linear patterns and figure out which ones are growing faster than others. So if we see a graph that has a really, really steep line that's pointing up really quickly, we can assume that it's a really fast growing pattern. Now, as we get closer to 8th grade, we're going to change our language from describing steepness to describing slope, which is why I put the word slope in parentheses, because it's a word that you're going to come to eventually, but we're just not ready to use it just yet. So steepness can tell you how fast or how slow a pattern is changing. How fast or slow a pattern is changing. So let's use another money example because I think that's something that we all can relate to. So in our money example, we're going to pretend that we're comparing two bank accounts. In one bank account, we add $10 each month versus adding $100 each month. Oops, not moth. Month with an N. Okay. So obviously if we think about this, and we had to choose between these two options, I think we would all choose to add $100 to our bank account each month. I know personally I would like that option. But the idea here is to see how the difference between 10 and 100 changes the steepness of their graphed lines. So even though this seems like a really silly example, it's going to help us see that steepness a little more clearly. But I want to add a starting value. So no matter which plan we were to pick, either way, we're going to start with $50 in that bank account. So because we're not starting with $0 in the bank, starting with $50 in the bank is going to actually make our line start in a different position. So let's label this graph and sketch some lines really quickly. So I skipped every other label, but every dash mark is going to represent $50. So we've got 50, 100, 150, 200, 250, $300. And let's mark off some months. We'll just go up to 5 for this short example. So because both bank account plans would start with $50 in the bank, I'm going to automatically start my line at the $50 mark over here. Let's model the $10 pattern first. So after 1 month, we've added $10 to the bank account. So our line doesn't move very far, goes up just a little bit. After 2 months, we add another $10. So we're up to $70. 3 months, we're up to $80. 4 months, we're up to $90. And after 5 months, we've hit the $100 mark. Now my lines aren't in an exact straight line, or excuse me, my dots are not in an exact straight line, but that's okay. Go ahead and connect them as straight as you can. So we've got a slow growth pattern starting here. Let's get a different color. The $100 a month plan also starts with $50 in the bank. So I'm also going to start at this $50 mark on my y-axis. This time we're adding a lot more money as the months go by. So starting with $50, if I add $100, that's going to bring my total up to $150 after the first month. So I put a dot right here at $150. 1 month later, I've added another $100. So I go all the way up here. Now I've got $250. A month later, I'll end up with $350. Quickly run out of space on my graph to keep going. Don't forget to label your lines so you can tell which one is which. Once we've got this visual done, it's pretty easy for us to see that $100 a month is going to grow faster. And we knew that based on the setup of the problem, but it's also nice to be able to actually visualize it as well. One last thing I want to add to our notes before I give you some work time. And this takes it all the way back to the starting point of the graph. So in this example, we started with $50 in the bank, which is why I started the graph at 50. That's a really key point that we have to observe when we're looking at linear functions. The starting point of a linear graph is called the y-intercept. Intercept. It sounds a lot like intersect, And that's how I like to remember it, because the y-intercept is the place where the line intersects the y-axis. It can be a little bit confusing, and we'll review this as we go throughout the chapter, so don't worry about that. Using some arrows to show my example. And then we'll just write it down one more time to clarify. The money started $2 in the bank. At the $50 mark. My plan for today was to add some notes on the student side because you guys took that time to trim the packet page and glue it or tape it over there. But to save some time and get you started on homework right away, we're going to wrap this up right now. Make sure that you're meeting expectations throughout the day and being kind to your substitute. I'll see you guys on Friday. Have a great afternoon.